I'm Anil Kumar. Welcome to my series on mathematical induction. We'll take a few important formulas which can always be used to simplify and solve many mathematical questions. Now here our approach will be to treat all of them as a statement. We'll say that is a mathematical statement in natural numbers, right? So n is a natural number for us. And when we say 1 plus 2 plus 3 plus 4 and so on till n is equal to n times n plus 1 over 2, where n belongs to natural numbers, that is a statement translated into mathematical equation, correct? Now the idea here is to prove that these things are true. So statements means it could be true or a false, right? So it could have only two answers, true or false. So we'll approach in a way so that we could prove that this formula can be used for that kind of a sequence. So we have taken up examples where we have sequences, and in this case we are talking about sum of a sequence, so that becomes a series. And we are saying the sum of natural numbers is n times n plus 1 over 2, which is known to most of you. We'll prove by the method of induction that this is true. So the strategy here is that initially we'll just substitute the value 1 and say that p of 1 is true. And the second step will be, we'll say let p of m be true. And then we'll show that p of m plus 1 is true. So once we do that, then by induction we have proved our statement, right? So at this stage we'll say, well, we have done our job, so the statement is true. And in most of the cases, I should say all of the cases which we are dealing with, it is true for set of natural numbers. So we are dealing with n which belongs to set of natural numbers. So is that clear, right? So that is the whole objective in short. Now let us see how to do it. Now here again I have a very different approach from most of the books. I will be solving both the sides so that we could clearly get an solution faster, right? So, and I have very limited space to work with, so I don't really want to go from one side to the other. I'll solve both the sides and say, well, this is true, okay? Use mathematical induction to prove the formula 1 plus 2 plus 3 plus 4 plus n so on for n natural numbers is n times n plus 1 over 2, n belongs to natural numbers. Then we have another question where we are saying sum of squares formula and then sum of cubes formula. Now, these are three very important formulas which all of you should always remember. So let's begin with the solution for the very first one, which is 1 plus 2 plus 3 plus 4 plus so on till n is equal to n times n plus 1 over 2. Right? So as I was saying, first step will be, we'll just substitute 1 and then check what is, so this is a statement where there are n natural numbers. So we say, what is p of 1 equals to? So when I say p of 1, I'll just substitute 1 here. So I get 1 times 1 plus 1 over 2. Well, that is 1 times 2 over 2, and that is 1. Well, that is true. If we have just one natural number, then its sum is 1, right? So this one is true. So next step here is we say let. Now we say let p equals to m be true. So if that m is true, then in that case 1 plus 2 plus 3 plus so on till m is equal to m times m plus 1 over 2, correct? So we have assumed this to be correct. Now the idea is to prove that p of m plus 1 is true. So if I substitute m plus 1, that means we are going to one additional natural number in this series. So the series now becomes 1 plus 2 plus 3 and so on plus m plus 1. And using this formula, if at all it is true, We'll replace m with m plus 1, correct? So we get m plus 1 times, within brackets, m plus 1. This is m plus 1 for m, right? Plus 1. You get the idea, right? So let me write another bracket here. Divided by, of course, 2. So we need to show that this is true for the statement to be true. That's the whole idea. How by induction? We assume that it is true for m, and for additional number, one more than m, if it is true, then for all natural numbers, it should be true. Perfect. Now here is the approach. We have already seen that this could be written as the combination of these two, right? Now, first part of it is m times m plus 1 over 2. And then we have plus m plus 1, correct? Okay, so what we can do here is that we can take m plus 1 common and see what do we get. Well, so this is equal to this. So if I take m plus 1 common, let me go straight this time. Let's take half common here and then simplify. So if I take half common, and then what do I get here? I get m times m plus 1 plus 2 times m plus 1. Is it okay? Now, I could take m plus 1 common here, so I get half of, when I take m plus 1 common, what do I get? I get m from here and 2 from there. I get m plus 2, right? Okay. But what I need is m, I already have this term half here, right? M plus 1 is there with me. This is m plus 1 plus 1. Oh, that is nearly done, right? So we could now write this as half of m plus 1 times. Now m plus 2 could be written as m plus 1, right? Plus 1. So let me put this in bracket. So as soon as I do that, I get my right hand side. Do you see that? So I've shown that the left side is basically equal to the right side. So this is exactly what we expected, correct? So we have shown that this statement is true for all natural numbers. Therefore, statement is true for n belonging to natural numbers. Is that clear to you? So that was the idea. So whenever you add a term here, then the approach here to solve any one of these will be exactly same. You have assumed the first part of it, write that. Next part of it, write that. Add them and try to get the right hand side. And once you get the right hand side, your job is done. You've shown that this particular formula not only works for just m, but m plus 1 also, and therefore it works for all natural numbers. Is that clear, right? Now with this in mind, let's move forward and take up the next question now. So now here is our second example. We'll use mathematical induction to prove the formula 1 square plus 2 square plus 3 square plus 4 square till n square is equal to n times n plus 1 times 2n plus 1 divided by 6, where n belongs to natural number. So basically, sum of squares of natural numbers formula, right? So first step is we need to figure out what is p of 1. Is this formula true for p equals to 1? So when you substitute 1 here, you get 1 times 1 plus 1 times 2 plus 1 over 6. Now that gives you 1 times 2 times 3 over 6, and that is indeed 1. So that means this formula works for 1, right? So that is our first step. Okay, so that is our step number 1. Now step number 2 is that we will assume that this formula works for m. So we'll say let p of m. Now when we say p of m, that is a statement, right? Written in the form of an equation. So n is any natural number. Let m be one of those natural numbers. In that case, 1 square plus 2 square plus 3 square plus so on till m square should be equal to m times m plus 1 times 2m plus 1 over 6. for m which belongs to set of natural numbers. So we have assumed this is true. What we need to really prove is that the next value should also be true, right? We have to prove. This is what third step is, which is basically to prove. Right? So we need to now prove that p of m plus 1, which will be 1 square plus 2 square plus 3 square plus so on, m square plus m plus 1 whole square should be equal to, let me change the thing. So we'll replace this m with m plus 1 times m plus 1 times 2 times m plus 1. So we're replacing every m with m plus 1, right? Plus 1 divided by 6. This is what we want to prove. Is that clear to you? Correct? Now, the approach is that we already have assumed that this part is true, right? So we know what is the sum of these numbers. We'll add that additional number to it and then show that everything on the left is same as that on the right. Is that clear to you? So we could write this as m times m plus 1 times 2m plus 1 over 6 plus the new term which we added, which is m plus 1 whole square, should be equal to all this. Correct? Now let me write this in a simpler form, which is m plus 1 times m plus 2, right? Times, let's open this up, 2m plus 2 plus 1 over 6, right? So I want to simplify this also. It'll be easy for us to compare, right? So on the left side, I could take m plus 1 over 6 common. So we'll take m plus 1 over 6 common, right? So we are left with m times 2m plus 1 here, plus, of course, m plus 1 here, right? And on the right side, let me go further and simplify this portion, which is m plus 1 times m plus 2 times, this is 2m plus 3. And everything divided by 6. Okay. Now, on this side, if I open this, should be multiplied by 6. I took 6 here, so I have to multiply this by 6. Okay. 6 times, right? So we took 6 here. So let's open this up. So we get m plus 1 over 6. And here we get 2m squared plus m plus 6m plus 6, right? Now, that gives us m plus 1 over 6, 2m squared plus 7m plus 6, correct? Okay. Now, let's see what do we have here. We have m plus 1 over 6. You could factor this and write in those terms. You could do that. Perfect. So, either way it could work. So, if we already have m plus 1 and that portion is at this. So, we could factor this, right? 6 times 2 is 12. And how do you get 7 out of it? So, 4 times 3, right? So, we could write this as, okay, let me work on this side. And then we'll show that this side is same as that. Is that okay? Or we could have expanded that and shown both of them. So let's go one more step from here. So this is equal to m plus 1 over 6. And what we have here is 2m squared plus 4m plus 3m, right? Plus 6. And that gives you m plus 1 over 6. And we can take 2m common. So we get m plus 2 here, and we can take 3 common. We get m plus 2 there also, right? And then we can write this as m plus 1 over 6 times what? So m plus 2 is common. And we get 2m plus 3. Correct? That is our right side. Now I could write this as m plus 1 times m plus 2 times 2m plus 3 over 6, and that is equal to the right side. Is that okay? So either way, so this is your right side, correct? So both are same. So we have shown that if we assume that P of m is correct, then P of m plus 1 is also correct, and therefore the statement is true. Is true for n belongings to natural numbers. Is that okay? So sum of squares formula for you now is n times n plus 1 times 2n plus 1 divided by 6. Now let's see what happens to sum of cubes. So here is another very important equation. Sum of cubes is n times n plus 1 over 2 whole square. So we'll prove this formula by induction. So first step, let's check for 1, right? So when n equals to 1, if I substitute here, I get 1 plus 1 over 2 whole square, right? And that gives you 2 over 2 whole square, which is 1. So that is true. So we have seen the first step is correct. So now we'll say let P of m be true. Correct? So we'll do now for P of m, and then we'll check for P of m plus 1. Correct? So P of m will be 1 cube plus 2 cube plus 3 cube plus so on till m cube, right? Should be equal to what? So n will be replaced by m. So we get m times m plus 1 over 2 whole square for m belongings to natural numbers. Is it okay? So we'll say that this is true for us. And now we need to prove what? We need to prove that this holds good for m plus 1 also. So we'll now check what is P of m plus 1 equal to, right? So m plus 1 will be 1 cube plus 2 cube plus 3 cube plus so on till m cube, an additional term, m plus 1 whole cube. Now, if this formula is true, n has to be replaced with m plus 1. So we get m plus 1 times m plus 1 plus 1 over 2 whole square, right? So that is what is expected for m belongings to natural numbers. Clear? Now from the previous statement, what we know? We know that these terms add up to what, right? So we know that these terms add up to this, correct? So we could now write this as first group of terms as m times m plus 1 over 2 whole square, right? So this is what we could write, first group of terms. And here we have m plus 1 whole cube, correct? So that becomes our left side. Okay, so let's work with left side and see what we could do better. So if you open this up, let's take it on this side. We get m square and we have m plus 1 whole square over 4, right? And then we have plus m plus 1 whole cube. Now, we could take m plus 1 square over 4 common. So we get m plus 1 whole square over 4 as common. And inside we are left with m square plus m plus 1. Correct? Since we took two of them, we got this m plus 1 times 4, of course, right? So let me use different thing, times 4, right? Yeah. So that's what we get. So we could write this as equal to m plus 1 over 4. M plus 1 is squared. And within this bracket, we have m square plus multiplying by 4, we get 4m plus 4. Now, this is a perfect square. So I could write this as m plus 1 whole square over 4 times m plus 2 whole square. Well, that gives us m plus 1 all are square, right? Times m plus 2 over 2, right? So we could square all of them. So that is very close to our formula, right? This is what we want. So now we could write this as equal to m plus 1 times. So this is m plus 1 plus 1, right? So we can write this as m plus 1 plus 1, correct? Over 2 whole square. And that is the right side, correct? So we have shown that this formula works for Pm plus 1, right? So therefore, statement is true for n belonging to natural numbers, right? For all n, right? Since it is true for m plus 1 also, right? It has to be true for all natural numbers. So in this video, you learn how to find the basic formulas, rather prove them by induction. We saw the sum of natural numbers, sum of squares of natural numbers, and sum of cubes of natural numbers. Now in the next video, we'll take up other combinations using product and reciprocals of these natural numbers, and those will form an excellent list of formulas for you to work in future whenever we have something related to sequences and series. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.